Hello learners, I am Dr. Munish Kumar Bharadwaj from School of Engineering and Technology of IGNOU. As you remember, we were discussing about the defects in timber. As you know, the defects in timber can be categorized into 5 different categories. First, defects due to conversion. Second, defects due to fungi. Third, defects due to insects. Fourth, defects due to natural forces. And defects due to seasoning. Out of these 5 categories, in our last lecture, I discussed with you defects due to conversion. In this lecture, I will discuss with you defects due to fungi, defects due to insects, defects due to natural forces. And the last one, the defects due to seasoning, will be covered in the next lecture. So let us begin with defects due to fungi. Fungi are minute microscopic plant organisms. They attack timber only when the following 2 conditions are satisfied simultaneously. Number 1, the moisture content of timber is about 12 to 15%, and number 2, there is a presence of air and warmth for the growth of fungi. If any of the above condition is absent, decay of wood due to fungi would not occur. What are different defects due to fungi? The defects caused in timber by fungi are blue stain, brown rot, dry rot, hurt rot, sap stain, wet rot, white rot. Now let us discuss one by one. First, blue stain. In blue stain, sap of wood is stained to bluish color by the action of certain type of fungi. Next is brown rot. The term rot is used to indicate decay or disease of timber. Certain type of fungi remove cellulose compounds from wood and hence wood assumes the brown color. This is known as brown rot. Now, dry rot. Certain type of fungi feed on wood and during feeding they attack on wood and convert it into dry powder form. This is known as dry rot. Dry rot occurs at places where there is no free circulation of air, such as improperly ventilated basements, rooms, etc. Unseasoned softwoods and sapwood are easily attacked by dry rot. If timber is not properly stored after being felled down, it is liable to be attacked by dry rot. It is not necessary to have damp conditions for the development of dry rot. Dry rot is also caused by charring, painting, and tearing of unseasoned timber. So these are also the reasons for dry rot. Now next is hurt rot. This is formed when a branch has come out of a tree. In such a case, hurt wood is exposed to the attack of atmospheric agents. Ultimately, the tree becomes weak and it gives out hollow sound when struck with a hammer. So this is hurt rot. Now let us move to the sap stain. Certain type of fungi do not bring about the complete decay of timber, but they feed on cell contents of sapwood. In doing so, sapwood loses its color. This is known as sap stain and it generally occurs where moisture content goes beyond 20% or so. Now let us discuss wet rot. Some varieties of fungi cause chemical decomposition of wood of the timber, and in doing so they convert timber into a grayish brown powder. This is known as wet rot. Alternate drying and wetting conditions favor the development of wet rot. If unseasoned or improperly seasoned timber are exposed to rain and wind, they become easily liable for attack of wet rot. So these are the conditions when wet rot may develop. How we can prevent the wet rot? The well-seasoned timber should be used for exterior work or for underground work, and it should be covered by tar or paint for protection against moisture. So that way we can prevent wet rot. Now let us discuss white rot. This defect is just opposite of brown rot. In this case, certain type of fungi attack lignin of wood, and wood assumes the appearance of a white mass consisting of cellulose compounds. Now, these were the defects due to fungi. Now, let us move to the defects due to insects. Insects responsible for the decay of timber are beetles, marine borers, and termites. These are the three main insects. So let us begin with beetles. Beetles are small insects and they cause rapid decay of timber. They form pinholes of size about 2 mm diameter in the wood. They attack the sapwood of all species of hardwood. Tunnels are formed in all directions in sapwood by the larvae of these beetles. The timber is converted into fine flour-like powder. They usually do not disturb the outer shell or the cover. Hence, timber piece attacked by beetles may look sound till it completely fades, because it is not disturbing the outer shell. So you will not come to know about the decay till it completely fades. Now, pinhole borers. The standing trees or recently felled logs of several softwoods can be attacked by pinhole borer. You see the picture of the pinhole borer in the figure. The attack ceases and dies when the timber is converted and dried. Attack is more common in sapwood than hardwood. The defect in timber takes the form of circular holes or short tunnels 0.5 to 3 mm diameter, mainly across the grain. It is important to note that it is mainly across the grain. The holes are dark stained and contain no bone dust. Now next is house longhorn beetles. House longhorn beetles are a risk to softwood in roof voids or pitched or flat roofs where there is a sufficient warmth. They can attack dry softwood. You see here in the figure the picture of a house longhorn beetle. Next is furniture beetles. Furniture beetles is the most common insect attack in some places. This can attack dry sapwood and even dried hardwood. In the figure you see the picture of furniture beetles. Wood wasp. Wood wasp attack standing trees and logs. The attack ceases and dies when the timber is converted and dried. The tunnels formed are circular and are filled with tightly packed bone dust. Next is marine borers. These are generally found in salty water. Most of the varieties of marine borers do not feed on wood, but they make holes or bore tunnels in wood for taking shelter. Means they are not eating it but making holes or bore tunnels for taking the shelter. The diameter and length of these holes may go as high as 25 mm and 60 mm respectively. means diameter can be up to 25 mm and the length of the hole can be up to 60 mm. The wood attacked by marine borers loses color and strength. No timber is completely immune from the attack of marine borers. In the figure you can see the picture of the timber attacked by marine borers. Next we move to termites. These are popularly known as white ants and they are found in abundance in tropical and subtropical countries. In our country, there is a lot of attack of termites. These insects live in a colony and they are very fast in eating away the wood from core of the cross section. Here in the figure you see the picture of termites. Here this figure is enlarged, so you see a large size of ants. In actual, these are not as large, they are small in size. What they do to the timber? They make tunnels inside the timber in different directions and usually do not disturb the outer shell or cover. Hence, timber piece attacked by termites may look sound till it completely fails. Very few good timbers such as teak, sal, etc. can resist the attack of white ants. Such timbers have certain chemicals in their composition and the smell of these chemicals is not favorable for termites. Because of that, these timbers are not attacked by termite. Now let us move to defects due to natural forces. There is a long list of the defects caused by the natural forces such as bulbs, chemical stain, coarse grain, dead wood, knots, shakes, twisted fibers, upsets, water stain, wind cracks. So these are the defects caused by the natural forces. We will discuss one by one. First, let us begin with bulbs. These are also known as excrescences, means a distinct outgrowth on a body or plant, and they are particularly formed when a tree has received shock or injury in its young age. Due to such injury, the growth of tree is completely upset and irregular projections appear on the body of timber. In the figure, you see the lumps on the trunk of the tree. These lumps are bulbs. Next is chemical stain. In this, wood is sometimes discolored by the chemical action caused to it by some external agency. This is known as chemical stain. As you see, the different color in the timber cross section, this is caused by the defect called as the chemical stain. Next defect is coarse grain. If a tree grows rapidly, annual rings are widened. It is known as coarse grain timber and such timber possesses less strength. Next is dead wood. Timber which is obtained from dead standing trees contain dead wood. It is indicated by light weight and reddish color. So these are the two identities. You can identify the timber which is dead wood, that it is of light weight in comparison to the healthy timber, and also the color is also reddish. Now we move to knots. Knots are the bases of branches or limbs which are broken or cut off from the tree. The portion from which the branch is removed receives nourishment from the stem for a plenty long time, and it ultimately results in the formation of dark, hard rings which are known as knots. As continuity of wood fiber is broken by knots, they form a source of weakness. Means the timber having knots is a weak timber. Now, let us talk about the classification of knots. Knots are classified on the basis of their size and form. The table shown here gives the classification of knots on the basis of their size, form and quality. So what is there in the table? In second column you see the type of knot, and in third column you see the size. So first one is the pin knot. The size is diameter up to 6.5 mm. A small knot, diameter between 6.5 and 20 mm. Medium knot, diameter between 20 mm and 40 mm. Then large knot, diameter greater than 40 mm will be known as large knot. So it is the classification based on the size first. Now let us look at the classification of knots on the basis of form and quality. Here in this table you see the three columns. Second column gives the type of knot, and third column gives information regarding that particular knot. So first let us talk about dead knot. In dead knot, the fibers of knot are not properly interconnected with those of surrounding wood. Hence it can be easily separated out from the body of the wood. It is not safe to use wood with such a knot for engineering purposes. Next is decayed knot. It is also known as unsound knot, and it is formed by the action of fungi on wood. Then third type of knot is live knot. It is also known as sound knot. It is free from decay and cracks. It is thoroughly fixed in wood, and hence it cannot be separated out from the body of wood. Presence of such knots make wood difficult to plane. However, wood containing such knots can be used for engineering purposes. Then fourth one is loose knot. It indicates preliminary stage of dead knot. The fibers of this knot are not firmly held in the surrounding wood. Then fifth kind of knot is round knot. Cross section of this type of knot is either round or oval. It is obtained by cutting the knot at right angles to its long axis. Then next type of knot is tight knot. It indicates preliminary stage of live knot. The fibers of knots are firmly held in the surrounding wood. So these are the classifications of knots. Earlier I discussed with you that classification based on size, and in table 2 classification of knots based on form and quality. Now let us look another defect, that is rind galls. Rind means bar and gall indicates abnormal growth. Means here you can say rind gall means abnormal growth of bark. Hence peculiar curved swellings found on the body of a tree are known as rind galls. They develop at points from where branches are improperly cut off or removed. In the figure, you see the rindgall on the tree. Now let us talk about another defect, that is shakes. These are cracks which partly or completely separate the fibers of wood. There are different varieties of shakes. What are these? First one, cup shakes. Second, heart shakes. Then third is ring shakes. Then fourth is star shakes. And fifth is radial shakes. So let us discuss first cup shakes. These are caused by the rupture of tissues in a circular direction. It is a curved crack and it separates partly one annual ring from the another. It develops due to non-uniform growths of tree. It may not prove to be harmful if it covers only a portion of the ring. Next is heart shakes. These cracks occur in the center of cross-section of the tree and they extend from pith to sapwood in the direction of medullary rays. These cracks occur due to shrinkage of interior part of tree which is approaching maturity. Heart shakes divide the tree cross-section into 2 or 4 parts. Here in the figure you see the picture of heart shakes. Then ring shakes. When cup shakes cover the entire ring, they are known as ring shakes. Here in this figure you see in the dark circle which is ring shake. Then star shakes. These are cracks which extend from bark towards the sapwood. They are usually confined up to the plane of sapwood. They are wider on the outside ends and narrower on the inside ends as shown here in the figure. They are usually formed due to extreme heat or frost. Radial shakes. These are similar to star shakes, but they are fine, irregular and numerous. This is the difference between the star shake and radial shake. They usually occur when the tree is exposed to sun for seasoning after being felled down. They run for a short distance from bark towards the center. Then they follow direction of annual ring and ultimately run towards pith. Here you see in this picture the radial shakes. Then twisted fibers. These are also known as wandering hurts and they are caused by twisting of young trees by fast blowing wind. The fibers of wood are twisted in one direction as shown here in the figure. You see the twisted fibers. Timber with twisted fibers is unsuitable for sawing. It can however be used for posts and poles in an unsawn condition without cutting. Next is upsets. These are also known as ruptures and they indicate wood fibers which are injured by crushing or compression. Upsets are mainly due to improper felling of tree and exposure of tree to fast blowing wind in its young age. Here the figure shows a timber piece with this defect. Now next we move to water stain. Wood is sometimes discolored when it comes into contact with water. This is known as water stain and this defect is usually found in converted timber. Now we move to another defect, wind cracks. If wood is exposed to atmospheric agencies, its exterior surface shrinks. Such a shrinkage results in cracks as shown here in the figure. These are known as wind cracks. So here in this lecture we discussed about defects due to fungi, defects due to insects, defects due to natural forces. I hope you must have enjoyed. In the next lecture, we will discuss about defects due to seasoning and decay of timber. So, thank you.